Hey guys, welcome to System Design Fight Club. Now we're going to move on to chapter 11 in my predictions for Alex Shu's upcoming book. It is People You May Know, roughly Tinder, but for business people. If you're looking at like LinkedIn or it's going to work similarly. It's Tinder. So the resources I was looking at for this one was Tinder's design on high scalability. Somebody on my Discord channel gave me that one. It was really helpful. I've been looking at the following for figuring out how to do some of these. So I decided to just go ahead and throw in the Wikipedia links. For the requirements on this, users will be able to update their account, their profile info, which would change how they show up in recommendations. Users will have other accounts suggested for them to follow because, it says people you may know. It's saying like, hey, maybe you should follow this person. Do you know this guy? You should connect with them, obviously. Okay, and now one of the most important parts, since this is an ML thing, we need to talk about the data model. So this is another recommender system. That's going to be a trend here. This one is actually going to be collaborative filtering, I believe. And so that will be a classifier where it's using the context of similar accounts, where similar counts are used to determine what else, who else you should probably be following. So it's like if this other person really similar to your own account is following this guy, then you should probably also be following this guy. Is how it kind of builds up its intuition for doing recommendations. And this one, unlike the previous, it's just gonna be like one big previous being chapter 10. It's just one big data model. It's not user specific. And then since it's built off of user profiles, sometimes you extract information out of it. So for example, in your profile's bio, you have some text data again. And so TF, IDF, term frequency, inverse document frequency for determining word strength. It's called like word strength is kind of like the best way to put it. I didn't explain that in chapter 10, sorry. That is probably going to be good to do here again. And then again, stimming, such as turning the word running into run, or if you have like programmer to programming also turns into program. Again, remove stop words, stuff like that. And again, it's going to be another classification algorithm. GBM, really common. XGBoost is, another popular. It's a popular library for gradient boosting machines. And I mean, similarly to the last one, there's you can use neural nets, use random forest here. You can use naive Bayes possibly is something that some people like. You could actually probably just look through the scikit-learn library. That's how I learned how to figure out how a lot of these different models work. Stochastic gradient descent is another type of classifier. I think we've probably spent enough time on that. We can probably hop into the diagram now. So I've got two different, well, okay, I forgot another requirement. It's that users can follow other accounts. So you can start following another account, and then that is whether or not you follow somebody is going to be the class for the labels in your classifier that you're going to be training against is whether or not you follow a different account, whether you follow an account or not. Okay, so 3 requirements here. I like to start with the entry points and exit points. So we are going to draw the 3 things for the browser, of course. So we need 3 things here. We will have the browser for following some account, user follows some account, submits a follow request. Submits follow request. Nice. Okay. Let's also have user can make or update their own profile. Cool. All right. Then we're gonna have user. So there's two different ways that there's gonna be two variations I'm gonna cover. One of them is how are you gonna see those accounts getting suggested? One of them is suggestions on your follow requests page. Another one is notifications. I don't know which one that Alex Shu is going to do. It's probably going to be the first one. It's probably not going to do the notifications approach. Yeah, but we're going to start with that easier one, which is user views their follow requests, which is a common place where you will see those similar account suggestions, people you might know. It's common to see them on your follower request page. All right, cool. All right. So we are going to need to get that data off of the backend service. So that would be we're going to call it the friend request listing service. Friend request listing service. Just like that. And we're going to have, we're just going to do something similarly to the previous one with those three different services right here, which of course can be combined in a variety of different ways. I don't care either way. It's just, you know, tons of different ways to approach that. And we'll just have like a retrieval service, which is getting that list of accounts. And then we'll have we'll call it an account ranking service. This is going to be very different. It's going to be a fair amount different. It's going to be a little bit more normal looking. Content-based filtering is really weird since it has like a model for every single user. So you have your user ID. Let's see everyone that is trying to follow me, and then also see some recommendations. So let's retrieve some accounts from nearby. You will have a list of accounts that you're going to, so there's going to be an account DB, user DB, account DB. I like using the word account instead of user here for clarifying some ambiguity around you versus the other users. You, I'm referring to as user, while the other users have accounts, and so you're following accounts. Okay, let's take a little detour and talk about user making or updating their own profile. We would have a profile management service. Management service. So when you are updating your account, you send a request in over there, and then it'll update your details in this database, and it'll turn back over here. Yep, successfully updated. And then there's a response. Yep, it was successful. And then your retrieval thing, so this would have like your latitude, longitude, your bio. You could have this in something like Elasticsearch, and then it'll have a inverted index for looking up people that like have certain things in their bio. And then for the retrieval service, it can like take advantage of that lat launch thing and stuff like that in order to pre-filter it down by a certain amount. So you can like look at, maybe it'll just recommend people that have worked at similar companies to you, stuff like that. It's going to do some pre-filtering though, so that it doesn't try and return the entire world for that first retrieval prior to the ranking. And so you get your list of accounts coming over here. And then we're going to want to rank those possible results. That might be people you might know. So then it's going to come over to here. It has the account ranking service. Again, so we're going to have this data model, and we want to have these normalized like features for it. We're going to actually rank the features. We can't rank the accounts directly. It would be better to have, so when I was looking at the way that Tinder set up, it looks like it does similarly do something like the last one where the things we're trying to evaluate are flattened into these like features. So we're going to have this accounts features DB. It's kind of like flattened or regularized, normalized in certain ways. And it's going to be similarly to the previous one. You'll do this like transform over here. I actually kind of want to talk about that a little bit more in detail this time. I'll make sure to get to that. But yeah, we're going to have transform task runners that are going to do whatever kind of regularization, normalization we want. That'll be a DB trigger again. I'll stick it over there. So we're going to have CDC with DB trigger. Cool. Put it into the account features DB. So you're going to have that list of accounts, and you are going to convert it into accounts with feature values. So you've got, you're passing in your user ID over here, paste it over here. You're going to get back a list of accounts. Whoa. Okay, I guess that is just part of the line. Have that, it gets sent over here, and then we're going to finally convert it into a list of accounts with those feature values. And so this is going to be, I'm going to go ahead and draw it like the last one. So we're going to have these rows that are the accounts. And then the columns are the features. You might have heard of like feature engineering. So that's actually, that's when you like roll your own features through doing some data cleaning and stuff like that. I won't get too into that here. So we have that, and then we don't have to fetch the data model off of a model store this time. It is just going to be hosted directly on the service because it's just the same for all users. So you're just going to have it directly there. Yeah, let's talk about how that one works. It's annoying when you don't know what the inputs and outputs of the model are, because it could just be actual accounts, account IDs, rather than what we're going to have, which is it's accounts with feature values, and it's the feature values that are used to convert this into accounts with scores. So you're running the data model against each individual account record. You're running the data model against each record, which is an account, and it's that record is a list of feature values over here, and you're turning it into a score. And so then you just have an account with a score. We're going to draw that like this. Hate how those lines are kind of sloppy. Okay. Yeah, so a list of accounts with feature values, and then you plug that into the data model, and then you just have accounts with scores, and then you can cut off anything that doesn't meet the threshold again, and then you would only be returning a list of accounts with scores that meet some threshold. Meaning some threshold value. Cool. Okay, we have that. I'm going to talk about how this thing gets deployed. That's kind of important. I'd really like to talk about that. But first, we're going to talk about this, which is what we are going to use for training our models. We're going to use that for training our models. So you can, of course, submit a follow request. So this is the follow request service. You can ask to follow somebody or directly follow somebody depending on the platform. And we're going to have the follow DB. I'll talk about the schema for this actually. Have the follow DB, and you can write the record into there. And then it'll give you a 200 OK, thumbs up. Yep, I've got your follow thing written into the database. Let's talk about the schema. So you have the user ID, that is your own account. And you'll have a record for everyone that you're following. We'll call that the following ID. And then this is the account ID of somebody else. So that's you, that's somebody that you're following. So you would normally do like a key range query to like see a list of people that you're following. So it would make the most sense to do have this as a partitioning key. I don't think you're normally going to go over this in a machine learning system design, but I will. And then your sort key is over here, and together they form the primary key. The whole thing is the primary key. I'm just going to go and do like that primary key. There you go. Yeah. Okay. So you have your follow stuff, and then this is whether or not you follow a person is going to, of course, be data for training your data model. So we're going to need to copy that over into the data warehouse that the data scientists are going to be using for running the little training jobs. So we're going to have a data warehouse. Super important to our data scientists and stuff. It's where you can do your analytical queries. You shouldn't be running those against your prod OLTP databases. So we are going to copy it over with just a DB trigger. I used to like to try to use a message queue instead, but Steve from A Life Engineered said DB triggers just totally work fine. Yeah, I have seen them in prod plenty of times, but I didn't start trusting them until recently. They're supposed to have overhead and stuff, but again, Steve, who's a principal engineer, says they're fine. So yeah. And we're going to say that, so like I said, the follows are going to be used as data. Follows become labels for the classes of the classifier when you're training your data model, your classifier. Okay. We also want to have you're going to be training it as like, this is going to be, the records of this will be the input data, and you're going to like join that with the actual follows to get the A class and B class. So you're also going to want to, this is an OLTP database, since we're actually hitting it against off the for like the data model requests. So you also need to have a copy of this over there. And yeah. It might look weird to you that I have so much of this like CDC with DB trigger stuff, but that's what I've seen done a ton in prod, is that you just, if there's something that the people want, that the data analysts or whatever want to have in their data warehouse, you just set up some kind of change data capture thing to make sure they get their copy. And again, message brokers are another alternative for making that happen. And so you're going to use the data from here, though, for training your data model. So we're going to have this for training. This is going to be the workers for training it. And then we're going to have our model object store. You are still going to have a model object store. It's not going to be quite like it was in chapter 10, because it's you only have one for all the users. Unless you're doing A/B testing, then you might have like two over here on the ranking service, and then you're A/B testing them as you're rolling a new one out. And this will be the model store, which is it's an object DB. So like, for example, S3. And so this is going to be the model training workers. And so you will pull in all that data from the data warehouse and kind of ETL job. And then it's going to take several hours to create its thing. If you're using Python, you can, when you have your classifier at the end, you can wrap it up into a pickle file. I've actually seen that as well used for a thing that I worked on. It was actually in an internship somewhere. Is a pickle file, and then you can go ahead and deploy the pickle file straight to a prod service. Yeah. So you have your model over here. So how do you actually, we want to like maybe have that running in production. And so you would have you'd like run a deployment. So let's have run a deployment. So like Jenkins or something. And so then like Jenkins is going to like grab that pickle file off of your object store. And you've probably seen a deployment run with Jenkins before. So this is just like your normal deployments that you might have done with Jenkins before, but it's going to happen with you're going to pull a specific data model pickle file off of your object store. It's going to be stuck on those machines that are running your service. And so you have a copy of that pickle file on each of the machines running your account ranking service. It's just right over there. Okay. Yep. I also wanted to cover the notification approach. So we have our approach, our variation 1 right here. I also want to do variation 2, and then we can also talk about this transform thing a little bit more. So let's do the first paste. And we're going to paste it one more time for the PCA analysis. That way it'll look similar to variation 1. It will be a little bit less jarring. Okay, so we have this, and then instead of having it do a pull, oh, I didn't even draw the last arrow where it was, there, counts with score meeting some threshold. Boom, there's your result. You had your user ID that you kicked it off with. Nice. Yeah. Okay, but I want this to be a notification this time. So instead, we want it to push to the clients. I guess I didn't have to do that. I could just reuse this one. We'll have user receives follow recommendation notification. So it's when you get pinged on your phone and it says like, hey, do you know this person? Like Facebook, you haven't logged into Facebook for like a month, and then you get this ping from Facebook and it's like, hey, do you know this guy? You should follow him. That's this. That's what this is represented with. And you will get a push over there. So we're going to delete this. So instead of doing a pull of it, like in the last one, we would instead have a push off of a daily batch job. To have a daily recommender batch job. So once a day, it is going to figure out who to ask. Do you know this person? Right there. So once a day, it boots up, it pulls in some accounts that are like in your geolocation or something. It's not going to pull the entire world. And then it's going to take that list of accounts, it's going to rank them, and then it is going to push them straight to your, it's going to, it still is going to, so it's going to rank them, and then whatever meets some threshold again, you want to set that threshold high so that it doesn't spam you with like 100 recommendations per day. Maybe like once a week. So it could even be like a weekly recommender batch job. Let's maybe do that. Let's say like maybe once a week, we'll have this thing come up and it'll go ahead and it'll set it so high. Maybe it'll just do like a key range query of, it'll just take the highest ranked account in this result and it'll push it to you. So once a week, it'll just take the highest ranked result there and it'll send a push notification to you for that. And that is how we're going to get it to work for the push notifications variation of this. And then I can talk about PCA, which I neglected in the last problem. I neglected talking about PCA. It's very important, particularly when you're working with text data. So when you have text data, you're going to have, there's like thousands of words, like the entire full breadth of however many words are in the English language is like the number of columns that would be there by default if you don't do something to shrink it to just features. So I didn't do this transform. The number of, God, I had rows, it should be columns. I'm sorry. So instead, the columns would be every word possible in the English language. So it'd be thousands or tens of thousands or hundreds of thousands. It'd be a lot. So that's why we don't want to do that. That's why we have features instead, which is like clustered up groupings of words. And in order to get it shrunk down like that, we're going to do this little transformation over here. And so there's a bunch of stuff for transforming it. We can do, so again, there's TF, IDF, term frequency, inverse document frequency, stimming, remove your stop words, like the, it's just pure noise. Every profile is going to have the word the in there. So it doesn't actually provide any kind of signal one way or the other. It's pure noise. And then you would have PCA, principal component analysis. And then you actually want to throw out the first few, let's zoom in here. Sorry about that. You want to throw out the first few principal components because they're pure noise. The first few components are always going to be pure noise. basically. I don't know if there's really a good rule of thumb for how many. If you don't remove your stop words, they are going to be what those first couple of components primarily consist of. Yeah, I could even make a note of that. We composed of those stop words, like they're not really going to mean anything. I think that's all I wanted to do in this approach. Yeah, okay. I mean, I guess I didn't really have to do this extra diagram then. I could have just done this right on top of one. Oh well. All right. I hope that was helpful. And again, I forgot the arrow right over here. Cool. And this is of course going to be in my Discord group eventually. Like all my other diagrams. Yeah. So that's why I'm taking care to fix that up. Anyways, thanks for watching. I hope this was helpful. This was my prediction for how chapter 11 of Alkshu's upcoming book is going to look. Yeah. So I'll let you guys go. Thanks again for watching. I'll see you next time. See ya.